Hi, welcome back to the Traefik video series. In the last video we covered how to provide HTTP encryption to our containers, or use Traefik as SSL terminator, and we use self-signed certificates to do that. And this was the diagram which this is the example in this diagram which I used to demonstrate that, and it highlights, actually it shows you that up to Traefik you can see it's the untrusted network. You can come here on port 80 and then Traefik would redirect you to port 443, which is HTTPS, and then Traefik would contact the backend services on your behalf, and all of this network is considered trusted network here, because that is what's behind Traefik and it's under your protection, so to speak. And of course the other services continue to talk to each other over normal plain text protocols, because it's a protected network or trusted network. Very well, so this is the example which we already covered in the previous video, and in this video we are going to cover Let's Encrypt. And first we are going to learn what exactly is Let's Encrypt. So you have very good detailed documentation or introduction to Let's Encrypt on its Wikipedia page, of course. But in short, I'm going to show you through this example that Let's Encrypt it was an idea by Mozilla and EFF people, Electronic Frontier Foundation, that we should encrypt the internet. So let's encrypt the internet, and that is where the name came from, Let's Encrypt. Main people behind Let's Encrypt are these people which are shown around this big box, and this big box represents ISRG, which is Internet Security Research Group. So the idea is that Let's Encrypt, which is shown in the middle here, is actually something which is provided as a service by these people, Internet Security Research Group. And this is the current state. Earlier it was just Mozilla and EFF, and these people, all of these people around EFF, Mozilla, Cisco, OVH, they are the main supporters, and there are also other notable supporters such as Linux Foundation, Eden Trust, which is itself a CA, a certificate authority, CoreOS, BBN Technologies, Stanford Law School, and ACME. All of these provide support and funding to ISRG, which maintains Let's Encrypt, which is a certificate authority, a free one. Let's Encrypt's idea is that it provides you free certificates, but it provides them for a limited time, like 90 days, and then you have to reissue them or request for renewal, and then it renews it for you. And there is an automated process to do that. So you contact Let's Encrypt, say, I am this person or this host, I need a certificate, and Let's Encrypt hands it to you. And all of this happens using something called ACME protocol. And I remember that in my childhood they were into cartoons showing ACME, and the acronym was at that time a company manufacturing everything. But here it's not that, it stands for automated certificate management environment. So it's a protocol which Let's Encrypt's clients use to access or request certificates or renew certificates. So since Let's Encrypt created this protocol or provided this service, it also wanted to first provide a client itself. So they created Certbot, and Certbot is very advanced, very good, very efficient client. What it does, it when you run it on your computer anywhere in the world and provided certain configuration, it goes and talks to Let's Encrypt and says and tells it that I am so and so, and I need a certificate for this host so and so. And Let's Encrypt then does certain challenges, and then it hands over the certificate, and Certbot then places that certificate in a certain location on your server and restarts the server. And you can know more about it here, certbot.eff.org, and you see that it provides it provides support for these software on a lot of Unix, Linux systems. It's very efficient, very easy to use, very easy to use. One thing about Let's Encrypt is that I want to highlight there is a how it works page on their website, which is very good in explaining how it works, but there is a small error in it, and I will explain that to you in a moment. But the most important things which you need to remember while working with Let's Encrypt is the rate limits. You can't abuse the system, or you don't want to abuse the system. So they have put some rate limits in place. You can only request certain number of certificates within certain number of time from a certain host using certain account or email account. And then they have two different types of services or types of certificates. One is staging certificate, which has more lenient or easier rate limits, or should I say higher rate limits than the production ones. So the production certificate has much tighter rate limits, and they are all listed here. In short, maximum production certificates in 1 hour is 5, and if you request more than that, then you are locked out for 1 hour. Very good. So let's go back to diagram. So these are the people supporting ISRG, which is providing Let's Encrypt as a service. Now Let's Encrypt looks like this. There are so many clients. There are many clients for Let's Encrypt which talk to Let's Encrypt, and they request certificate using ACME protocol, and they get the certificate back. And there are two types of certificates here, and I should have drawn them. One is the staging certificates, and the other ones are production certificates. Staging certificates are always invalid. So if you are thinking, what's the point? The point is that you first use staging. You first access staging servers to make sure that your mechanism to talk to Let's Encrypt and to get certificate is correct. If you start with the production right away and you have problems in your setup or in your automation, then you will hit the rate limit, and then you will be blocked out, and then you cannot proceed. So first and foremost, you should use the staging servers. And all these clients which you see on the left, there are many. I just listed some of them. They are capable of accessing both staging and production servers. Very good. So there's a list about all of them, which is on this URL here. Okay, let's proceed. So Let's Encrypt does two types of challenges. One is HTTP challenge and the other is DNS challenge. And these challenges are basically domain validation challenges. They just validate your domain. So in this diagram, you see that there is a web server on a public IP, and there is LetsEncrypt on the top, and this web server is hosting some websites, some hosts like nginx.wbit.com or multitool.lab.pragma.com. These are two examples I'm going to use in these to describe how it works. So why two types of challenges, HTTP challenge and DNS challenge? They both have pros and cons, or advantages and disadvantages, and you have to see which one fits your needs. So for an HTTP challenge, you basically need to make sure that the host you are requesting certificate for is reachable over the internet, and you control it, and you control the host. I have another copy of this diagram further below, so I can use different pens on explaining it. Okay, so in HTTP challenge, you just need to prove that you are publicly accessible and you control the host. So this is any LetsEncrypt client. It could be Traefik, it could be Certbot, it could be Nginx, it could be anything here. That's why I wrote X, which is running on this web server. This web server could be Apache, or it could be any other web server, but let's consider this is Apache. And you run this LetsEncrypt here, and you have these two hosts being served, right? You know virtual hosting, Apache virtual hosting, or any virtual hosting. So these two are two virtual hosts. Let me write virtual hosts here. These two are two virtual hosts running on this web server, and you want certificate for either one of them or both of them. It's up to you. So how it works, HTTP challenge, how it works. The LetsEncrypt client is configured to use, let's say, staging at the moment. It goes and talks to LetsEncrypt server, this one. Let me use this. So let's say the client initiates a request which goes to the staging server and says, I need a certificate. It sends a request. I need a certificate for multitool.lab.pragma.com. And the stagings and the, let's not call staging in production, just say LetsEncrypt says, all right, fine, you can have the certificate if you can prove that you own this host or you control this host. And here's a challenge for you. It gives it a file and says, can you place it somewhere under this host, somewhere, and some random file. The LetsEncrypt server gives it the name of the file and says, go and place this file in the directory for the host you want the certificate for, and let me know. So the LetsEncrypt client does that. So this was step one, and I'm just simplifying the whole process. It also involves a lot of signing of certain keys and all that, but let's forget that. We just want to see in the simplest form what happens. So the LetsEncrypt client Step 2 places a file at a place which the server asked it to. It asked it to put it under certain path with a certain name, and it does that, and then it tells the staging server, step 3, that I have done that. The staging server goes and checks and tries to fetch the file. If it can fetch the file, this is step 4. If it can fetch the file, then it has basically validated that what LetsEncrypt was, what the LetsEncrypt client was telling it was correct. It controls the host, and this host is reachable through this IP, whatever is mentioned in the international DNS. So it's important that LetsEncrypt client runs on a on the public IP which is listed in a certain domain under the domain which is, let's call it lab.pragma.com, and this host name is called multitool.lab.pragma.com, and it is configured here, and it does point to 1.2.3.4, because LetsEncrypt server will not try to fetch this file which the client has created for it. It will not try to fetch the file over the IP where the client is coming from. In fact, LetsEncrypt would go and talk to DNS and use that to get the file, whatever file it is, /file, which is here. So in that way, and if it points to the correct IP, then what LetsEncrypt server would be doing actually is coming here and then fetching the file, right? So it goes and talks to DNS, resolves the IP, talks to that IP address, gets the file, and then validates that yes, you're right, you do control the host, and you are having correct DNS resolution as well. So it hands it a certificate. So here's the certificate, step 5. Here's the SSL certificate, and LetsEncrypt then just places, step 6, places that certificate somewhere in the server and restarts the server. Step 7, restart service, web service. That's it. So this is how HTTP challenge works. You need to be on a public IP address, so you don't need to be able to modify DNS in this challenge. The client is not required to create any entries in DNS zone, but the entries existing in the DNS zone, they are verified by the LetsEncrypt server. So multitool.lab.pragma.com should already be pointing to this IP address 1.2.3.4 in the DNS. Similarly, I have another example here, nginx.wbit.com, and it's a vhost, it's a virtual host running on the same server, and when LetsEncrypt client wants certificate for this one, it goes and talks to the LetsEncrypt server in the same way. It goes and says, I am nginx.wbit.com, give me a certificate, and LetsEncrypt would go talk to some DNS wherever this wbit is hosted and resolve nginx.wbit.com and then make a connection on that And of course, it first asks the client to put a special file in the special location, and then goes on and checks it tries to fetch the file using the DNS name nginx.wbit.com/some path to the file, and if it fetches it, then it's validated and it hands a SSL certificate to the LetsEncrypt client, and it places it at a correct location, and it works. So that's how the HTTP challenge works. Let's talk about DNS challenge. In the DNS challenge, first we discuss why do we need it. So if you need a SSL certificate, a wildcard certificate, let me write wildcard certificate. If this is what you need, then you cannot use HTTP challenge, then you have to use DNS challenge. And how it works is, this is the client, and you want you have configured the web server to serve many hosts which are behind this domain lab.pragma.com, right? It could be Nginx here, it could be Tomcat, it could be www, it could be whatever X here. You want a certificate which works for all of them, so that's a wildcard certificate. So how it works is, the LetsEncrypt client on your web server goes and talks to whatever, okay, not whatever, let's still use the staging. It goes and talks to the LetsEncrypt server and says, give me a certificate, wildcard certificate for this domain lab.pragma.com. And LetsEncrypt server says, I can do that, but I want you to prove that you own this domain and you control this domain. And this time it's not asking it that prove me that you control this host. No, it says prove to me that you control the domain. And controlling the domain would mean that the client can control the DNS hosted zone, can modify it at will here at whatever the DNS provider the domain zone is hosted. So LetsEncrypt server says, prove to me that you control this domain by creating this special DNS record for me. So step 2 is a DNS challenge. A special record, and LetsEncrypt client then says, very well. It goes to the DNS provider and creates that special record. It could be a TXT record with some specific random random name or entry, and creates it and informs the LetsEncrypt server that I have done that. LetsEncrypt server then goes and talks to the DNS, or just queries the DNS for this zone, and queries that for this TXT record or whatever record it has asked it to create. If LetsEncrypt server is successful in fetching this record from the DNS information, then the server believes that the LetsEncrypt client is telling the truth. It does control the domain, or it has control of the domain it is requesting the wildcard certificate for. So step 5, this is step 5. This is messy, but it's a video, so you have been following the previous steps as well. Step 5, it gives it the SSL certificate, and then LetsEncrypt client places that wherever it needs to be placed in the server. That is step 6. And step 7, restart service, the web service and whatever. So you notice one thing, that in DNS Challenge, LetsEncrypt server is not contacting the actual host on the IP address. It's not fetching anything from here. So that means you can actually be on a private subnet and still get wildcard certificates. And that's the scenario 2 I want to talk about in DNS Challenge. So let's discuss that right away. Oh, I modified the main diagram, but anyway. DNS Challenge scenario 2 here. So how this works? This is a scenario. How does it work? You have a setup on the left side, and you have a private setup in your organization, on your network. You have a private network, and you have a web server running some company website. You have corporate Jira, you have Confluence, you have database, you have some internal users, and you have one reverse proxy to handle all of that. And the reverse proxy is also on the private network. It doesn't have a public IP address. So and it needs a wildcard certificate for this lab.pragma.com. What it does, it goes and talks to the LetsEncrypt server, and this is Traefik, which has a LetsEncrypt client built into its binary. So it goes and sends a request for certificate. Staging server, the certificate server gives it a DNS challenge, says, can you create this entry in lab.pragma.com, and that entry might be, let's create this txt record which contains this entry called 5ab7ef whatever. So the client goes, since it controls the DNS zone, it goes and modifies it, adds this entry, step 3, and then informs LetsEncrypt that I've done it. So LetsEncrypt certificate then checks or tries to get this certificate, and not certificate, sorry, tries to fetch this txt record. And when it is able to do that, it verifies or validates that the LetsEncrypt client controls this domain, and this domain which it is requesting the certificate for, the wildcard certificate. So domain validation completes, and LetsEncrypt server hands the certificate to the LetsEncrypt client, let's say step 6, and the client places it inside the server and then just simply restart the service with the new certificate, and it works. So it had nothing to do with the inability to be on the public IP address. All you needed to prove was that you control this domain, and you proved that by creating something inside it. And actually, if you are a private network, you can't have IP addresses here. Let's say Jira. Let's write Jira. Internet address 192.168.0.5. Is it possible? It's not possible to do that on a public network, on a public DNS, because this is a private IP address. So technically, you can just have an empty zone. You can have an empty zone just for the sake of existence, just for the sake of domain validations, and that's it. The client would just create entries here on LetsEncrypt's request, and when the certificate is handed back, I forgot to mention, when the certificate is handed back, then this is cleaned up, so this record is deleted, and in HTTP challenge the file is deleted as well. That's cleanup process, I forgot to mention. So this stays empty, and this was never there because this is invalid entry. So it's an empty host, empty DNS domain, which you just use for domain validations. That's it. Inside the network, you have your internal network, which is pointing correctly to jira.yourcompany.com, whatever that is, and it just goes there. So when this user writes, I want to reach jira.lab.pragma.com, the internal DNS has the entry. First of all, it goes to Traefik. Traefik has this valid wildcard certificate, and then it just allows the traffic to just go on, or allows the traffic. And remember, in the diagram, I'm sending all the traffic to staging, all the certificate requests to staging server. Staging server always issues invalid certificate. So I'm just assuming that after you have done all the testing of your mechanisms, then you switched to using the production certificates. Okay, this is one thing. I hope this explains or this clarifies HTTP and DNS challenges. There is one more HTTP challenge scenario, which I want to cover. And it's actually very simple. It doesn't actually need to be covered. It's a situation in which your web server is behind a router. So naturally, you would it's normally a home setup or something like that. So you can still get valid certificates from LetsEncrypt even if you have this setup. All you need to do is just forward port 80 and forward 3 inside across your router and point it to your web server, which is actually serving the websites or virtual hosts, and it works exactly the same way. The LetsEncrypt client talks to the certificate server. It asks it to place a file at certain location and then tries to fetch it, and when it's successful, it just hands it in the certificate, and that's it. So this was a very simple scenario. So we have covered HTTP and DNS challenges. Let's see how we can actually implement it in this scenario, or not actually this scenario. I have two other examples for you. One is HTTP example, HTTP challenge, and the other is DNS challenge. And let's see how it works.